Good evening and welcome to today's session. Really glad to have everyone here on a Saturday evening for Tech Talk number 6. The topic for today is correctly analyzing and understanding ICS-OT cyber incidents by our eminent speaker, Daniel Ehrenreich. Um, all right, so we'll have a quick introduction followed by expert talk of 55 minutes or 1 hour, and then a Q&A session for 25 minutes. Then a quick summary and closing remarks. So the house rules. So if you're driving, kindly stop at a safe place for the duration of the webinar. Hope you're aware of your surroundings and in a safe place. So the session will share shortly. And any questions you have will be managed by MS Teams Q&A. Do not enter in the chat message so that the questions are not missed. And as usual, feedback form will be shared at the end of the session. Request you all to enter the feedback, and a certificate of participation for this session will be provided to all those who submit the form. All right, so Daniel doesn't need an introduction. He's been quite a regular in the group and in the tech talk and the panel discussions as well. But anyway, to briefly share, so he has around 35 plus years of experience in cybersecurity, especially OT cybersecurity, and has chaired many conferences, events, training across the world. And really good to have you here, Daniel. And the another reason why we have here, why we have Daniel here is he recently published a paper which was also published in this ICS journal, and that's how we are here today to share his thoughts from his published paper. And do join us on our LinkedIn page, also on our WhatsApp group, and do follow us on our Twitter so that you are informed about our various events and other notification. So as I mentioned, Q&A answers will be managed by the MS Teams Q&A option that we have. And once the Q&A is done, if we have time, you can raise your hand and I will unmute you myself, and you can also verbally ask the question. This is only possible if you have enough time. So do wait for your turn and be patient. Do not enter any questions into the chat message. All right, so we'll be sharing the feedback form links anyway. So that's about it. And we just have an announcement. Probably we'll share more, but more on this once the session ends. Yes, Daniel, go ahead. I think I've stopped sharing, so you can start sharing as well.
Can you see now?
It's about to load. Yes, we can see your screen.
The full screen.
Yes, the full screen.
Okay, perfect. So first of all, it's great pleasure for me to be here. It's not the first time. Many of you know me from my participation in the various groups. Sometimes I make a comment that if somebody not like it, so I apologize up front. My intention is to really help people understand this great topic that it's called industrial control cybersecurity as it was introduced. This presentation is following a paper which I published in June in the ICSJWG quarterly newsletter, and obviously everybody can obtain that paper and read it. Furthermore, this presentation is available to everyone. So my intention is not to show you statistics about how many attacks happened and how the attacks are growing. I leave it for other people. My true intention is to help you understand the core topics related to industrial cybersecurity. So further to the short introduction, I'm a young expert, only 45 years of experience. And in the recent 10 years, I'm focusing my activity to training, to consulting, and most important is to help everyone to understand what is all about industrial control system cybersecurity. I would like to start with this slide because this slide is explaining the situation where we are. And you can see on the left side, so many IT people are around, so many IT experts, and everybody is busy dealing with IT topics. On the right side, you see the industrial control system operation, and you see the yellow circle, quite small number of experts. And this is the reason why we must do our best to spread this knowledge so everyone who is interested will have the opportunity to learn. In the center, the red circle is really very small. And I just want to indicate that there are probably 0 experts who can say they are experts in IT and also in the industrial control system OT. And this is the reason why sometimes the IT people and the ICS-OT people do not agree on how to deal with cybersecurity, about patching, about penetration testing, about using EDR, XDR, and all these things. So we really need to refer to this topic professionally, make sure that we understand everything correctly. So coming back to this slide, and I don't want to spend time on it because there is nothing new in that slide. We all know that protecting industrial control system is difficult because we don't have enough people, because systems are working around the clock. We cannot stop them. So what we can do, deploy strong perimeter physical security, deploy segmentation if possible, and where possible, very difficult to deploy segmentation on the existing systems, and for sure complementing and compensating measures. Why? Because these cybersecurity measures are not impacting the system. So you can deploy a complementing cybersecurity measures without changing anything in the hardware, without changing in anything in the software. And this is the reason why we like so much the cyber defense measures. Those people who say we need to do patching every week and we need to do penetration testing every month. So no, we cannot do that. We do not allow to do that. Why? Because every time we touch the industrial control system, something unexpected can happen, and this is obviously not a good situation. So let's continue after we agree on the main topic. I would like to show you this slide, and those friends who follow my activity, you already know that I'm a great supporter of the SRP, and usually I not read the slides, but here you can definitely read what is my opinion about the SRP, safety, reliability, and productivity. I must say that this is not yet accepted by any standard, because the standard organization are now hesitating if it will be a IAC, AIC, or SAICs like psych. There are still debates about it. Anyway, those people who follow me, important that you know that SRP is our target. Then how standard organization will call it, no worry. Those of you who are experts will understand it no matter what will be the name. Furthermore, when we are dealing with cybersecurity situation, you already know that there are only 3 possibilities, not 10, not 100, not 1,000: internally generated, externally generated attack, and supply chain related attack. Only 3 possibilities. Why it is so important? Because if we don't know from where the attack may start, we don't know how to deploy a cyber defense, and this is not good. So, yes, this is the situation, and we are still in the introduction stage because I hope that people are joining, but very soon we will go to the main topic of this presentation about analyzing the things. Furthermore, many people are using the Puru model. A Puru model is obviously very important, also very important for this topic, but I like to show this triangle picture because here I want to say everyone that the real-time operation is happening in Puru level 0, 1, and 2. Puru level 3 is supporting layer, and 4 and 5 are outside the industrial level, so no worry about it. But when we deal with protecting industrial control systems, we definitely need to look at layer 0, where the sensors and actuators are, at the Puru level 1, where we see the PLCs, RTUs, and the control computers, and Puru level 2, where we have the control room. So this is where things happen, and obviously the damage might happen in these layers, and this is important. When we deal with cyber attack, it's always important to understand the landscape, where we are. So we need to know how the attack was conducted. This is very important. I disagree with those people who refer to the Colonial, to the JBS, and to the Norway Aluminum and say, yeah, it was a cyber attack against the industrial facility. I say no, it was ransomware attack, not an attack on the industrial facility, and this is important. Why? Because if it was ransomware, then IT people should handle it. If it was directed to the control and the physical process, then in ICS-OT people should handle it. And this is critical. So, and we are going to talk about it longer today. Don't worry, I will cover this topic. Finally, today you will understand how many attacks happened worldwide in the past 12 years, because we all know that we started the topic on the day when the Stuxnet happened. Why? Because on that day when it happened, or month, wherever it happened, the stubborn industrial control people, like myself, I was among them, don't worry, I was among them in 2010. We understood that a system which is disconnected from the internet is not secure. That's what the day. Until May 2010, we were sleeping very well, and we said we are disconnected, we are air-gapped, all good. No, it's no longer true. When we are analyzing the attack, we need to look at the system logs. We need to understand exactly how attacker penetrated internally, externally, through a mail, and so on. And obviously, the entry point, if it was an internally generated or externally generated attack, very, very important to understand. So don't disregard this point. Don't just say, well, our plant stopped, so I don't care what really happened. No, it's not correct. We need to understand who was the target for the attack. What organization, the entire, or a big group? We need to understand it because we can learn from it. Remember, we cannot stop 100% an attack. We cannot stop. Attack might happen today, tomorrow, next month, next year, it will happen, and we must be protected. So by understanding who might attack us according to the 62443 security levels 1, 2, 3, and 4, who may attack us, we need to learn from the data collected after the attack. You know, when we are doing the incident response and collecting the details, we need to analyze it. We need to understand what was the goal of the attacker, what he wanted to achieve. He wanted to steal some data, he wanted to cause the damage to machines, and so on. And also look at the entire organization, human resources, finance, R&D. We always need to know why the attack happened, because then we can deploy some type of defense. And I now want to start already my presentation, and I want to surprise you with this slide. Cyber attack is not the main concern. Okay, not the main concern. Why? Because if I say that the number of industrial control system related attacks were relatively small, and we don't argue about the number, it was 20, 40, 60, or 90, but it was probably a 2-digit number over the past 12 years. So I say, no, that's not my main problem. I refer to 3 topics, which is also explained in my paper. First of all, my biggest concern is how my system, how my organization will react if there is a failure. We all know failure can happen at any moment. We don't know why. Somebody is requesting control. I don't know what it is. Okay, so
Daniel, your video, have you switched it off, or because we can't see you?
You cannot see me?
Yeah.
Oh, I don't know. I don't know why. But initially you could see me, right?
Yes, we could.
Now it's okay or not?
Not yet. Maybe you can turn on your camera again, or
No,
off and on.
now just leave it at this. We
Yeah,
should,
fine. Go ahead.
let's continue. Let's continue. So we need to worry about unexpected hardware or software. Then a hardware software failure because we have no control about it, you know, like a car, like a refrigerator, like a toaster, it may get broken at any moment. Yes, we need to be prepared how we deal with that. Then we need to worry about incorrect action by an authorized person. Somebody at your plant is making a mistake. We need to be ready for that. And only then deal with what I said earlier, internal, external, or supply chain originated attack. Now you are already reaching the first slide from my paper, and you can see it very clearly that we start with the term event, not an attack. Okay, now look at this. When there is an event, not be surprised that there are events which are not even detected. Not even detected. You know, perhaps your screen is getting black for 5 seconds and then all is okay. You're not even detected. You didn't have time to look at it. So start with the things that are not detected, or that they are detected but not analyzed. Somebody decided, yeah, yesterday evening we had some strange issues, but it was not analyzed because we didn't have any way to analyze it. So now it gives you the understanding why some people say, yes, there were thousands and hundreds of thousands of events which were not detected or were detected but not analyzed. Okay, and this topic we need to understand why, because if we will have better mechanisms, if we will be capable to detect everything and later analyze it, we will be in a better position to decide what type of attacks or how many happened. Then we are going down, and then we say, yes, there was a detected and analyzed and confirmed event. Now it's clear. And now you see in the three bubbles, the unexpected hardware, the incorrect action by an authorized employee, and in the center, you see the internally and externally generated cyber attack. So what can you do about it? If you have a hardware failure, you need to analyze why it happened and perhaps take some actions that this kind of failure will not happen in the future. If you have an incorrect action by authorized employee, what can you do? You just need to take that person, teach him, educate him. Here is the mistake that you did yesterday. Because of your mistake, we shut down our plant, and now you need to act better. So once we are now, you already see that the major problem is not cyber event. There are three possibilities. If we go further, okay, then we need to understand which zone of the plant was attacked. Because if the attack was in the IT zone, it's one topic. If it's an industrial zone like the Stuxnet, it's another topic. If it started in the IT and penetrated to the OT, it is another topic, like what happened in Ukraine. Okay, so we need to, Stuxnet was a direct OT attack. Ukraine was a remotely activated attack through an email, and the Colonial was a pure IT zone attack. So now we need to, if it was related to the IT, then obviously it's not our business. It's the CIA, confidential integrity availability, and let it to the IT people to handle. However, if the attack was directed to the industrial zone, we are already worried, because is there a risk to business continuity outage? I call it outage, and I call it as a small problem. What can I say? It's the big problem, but let's call it a small problem. Why? Because if the machinery was damaged, it's the bigger problem. If unfortunately a boiler exploded and some people get hurt, it's the huge problem. So now you already see that the SRP is pointing to the three possibilities: outage, damage, and risk to life of people. If I want to show this discussion on the chart, again, don't worry, read the paper. Okay, very important. You can learn from this paper, and this was the purpose for writing the paper, so you can learn from it. And on the right side, you see the IT-related impact, what happened in the Colonial pipeline. They were worried about loss of money. Yeah, it's the problem. Or some people worry about harming of privacy, like what may happen in the hospitals. Or an operation outage that the entire organization, it can be a bank, it can be a credit card company or anything, will not operate. So this is the IT related. I'm telling you, the whole purpose of this presentation is to help you to start to think in this direction. There is IT area, there is OT area. When we go on to the left side, you already see what I said before, and I like to repeat myself. Why? Because that's the way more people remember: operation outage, machinery damage, and harming people. Okay, so now you see the huge difference between what can happen in the IT area or what can happen in the OT area. Furthermore, we need to analyze the nature of the incident. What really happened? Did it truly impact the organization? Or it did not impact? The depth analysis of the event, where the attack was directed to layer 0, 1, and 2, or to layer 3, or maybe to the layer above. And we also need to look that in case the analysis did not result any cyber attack, then we need to do maintenance. So now we are looking further to what happened, and I show it again on the chart. So look at this beautiful, complicated slide, but I want to explain it. So now, going from the top to the down, you have a new industrial control system, and see on the right side again I'm pointing to a situation not detected. None of us will know why a screen in the control room suddenly became black for 2 seconds. We don't know what happened. We don't know how it happened. We don't have time to analyze it. So not detected, not analyzed. On the left side, we detected it, but we have no evidence, not analyzed, not reported. And remember, the major discussion between experts is that some people say that there were a huge number of attacks, but they were not detected, or detected but not analyzed and not reported. And even now in the USA, remember that there is a huge discussion about what needs to be reported, because if your screen suddenly become black for 1 second, maybe you don't need to report it. But if your screen become black for 2 minutes, yes, you need to report it. Someone need to analyze what happened. Furthermore, if we go down, then we look, there is an impact on the physical process. Impact on the physical process. And now look at it, how I'm going to refer to that. If I go right, I analyze it as a cyber incident, and I need to conduct some kind of maintenance on layer 0, 1, and 2. Remember the triangle that I showed you with the level 0, 1, and 2. However, and also look at the process, what really happened. Finally, I want to tell you that this must be documented in an internal report. If we go to the left side, okay, we look at something completely different, because now we see that it's not the physical process that was attacked, but the supporting process, layer 3. Layer 3, where we have the computers which are creating the production recipe and so on. So now again, you see, we need to do some inspection, some maintenance on layer 3. Maybe say you can find in layer 3 the processes which are supporting. Even the engineering station is at layer 3, not at layer 2. And finally, you see in the center, generate a report, an external report, meaning that you need to now report about it to the maintenance company. You need to report it to your management. Maybe you need even to report about it to the vendor of the products which were involved in that attack. So now you see how important is this topic to analyze what exactly happened, where it happened, how the incident happened. Just to go further, okay, and further explain, I say the IT orient that we have 4 possibilities, as I already mentioned earlier. Always remember these 4 possibilities. IT-oriented attack, no impact on the ICS-OT. For example, there is a problem in your HR department and nobody gets the salary on the date when it was expecting. We hope the salary will arrive a week later, no major harm. We trust our companies. Yes, it was an attack against our incident in our company, but it did not cause any harm because people told us we had a problem, your salary will come in a week later. The next possibility is that the IT-oriented attack, but it has indirect impact on the ICS-OT. Remember Colonial, JBS, Norway Aluminum, there were all ransomware attacks, not related to industrial control system, but there was an indirect impact. If the computers are not working, we are unable to communicate, we are unable to bill our customers, and the major story happens. Furthermore, the IT-oriented attack, now we are like the Ukraine, like the Saudi Aramco, we think that somebody penetrated to the IT, sent an email, a malvertised email, and that malware penetrated to the OT area because there was not a strong inspection, okay, and the malware penetrated. And only finally, the 0.1001% of incidents where we have direct impact on the ICS-OT. The Stuxnet, 2010, the Mauritius in Australia, that was the first wake-up call in 1998. The first wake-up call that something can happen, and read about it in the internet. There was an employee who was fired and he caused the major damage to his village. So now you see the 4 possibilities, and I would like to show it again as it is explained in the paper, okay? And now you see on the left side, we have the IT only oriented attack, okay, IT only, meaning that there is absolutely no impact on the OT. It's just IT related. And then we have the 3 possibilities which I explained. The IT attack, which have indirect impact on the industrial facility, indirect impact, I say it again, and like the billing, like what happened in the JBS, the meat factory, that there were not possible to operate. And I want to remind everyone what happened in the Norway Aluminum. Norway Aluminum was a ransomware attack which had indirect impact on the ICS operation. But proudly, I want to say that this organization was well prepared, and in the matter of very short time, they started to communicate via telephone, via fax, in the old-fashioned way, so they could minimize the impact on the big organization which had 40 factories worldwide producing aluminum. And I think we should be proud of them, that they knew what to do. They were prepared. Somebody was smart enough to ask a question. What are we going to do tomorrow morning if our IT organization is shut down because of whatever reason? I don't want even to mention. It can be failure, it can be incorrect action, it can be fire in the data center, who knows? But there is no IT. How we are going to communicate? And they had a process which was excellent. The next one, The next one, what happened in Ukraine? Okay, 2015, there was a cyber attack which penetrated to the industrial control facility. And here again, I want to proudly say that these people understood very quickly what happened, and in the matter of 6 hours, which is a very short time, they sent out the people in vehicles, in bicycles, who knows, to the city, and manually restored the power to 250,000 people. So why I'm saying that? You see, I'm saying it clearly. I'm proud of these people because they were prepared on how they are going to act. And finally, what I already mentioned, the Stuxnet and the Mauritius unfortunately, you can have physical perimeter defense, but no, it will not 100% protect you. Because there is no 100% defense. What can we do? So I want you to remember specifically that slide, and I want you to read the article which I wrote, not once. Read the article at least twice. If something is not clear, feel free to send me an email. Daniel, I'm not sure, or I disagree with what you wrote there. Yeah, maybe possible that we can find a way how to tune the explanation better. But when we are speaking about how to link between those experts who are saying 2-digit number of industrial cybersecurity attacks over the past 12, soon it will be 13 years, 2-digit number, compared to some other people that I don't want to mention their names. They claim millions of incidents happened in the past decade, millions of incidents. So how to bridge between these? And that's what I decided to, that's the reason why I decided to write this letter, this paper, to bridge between the millions and the 2-digit number. And I hope that by now you will have clear understanding. And when you hear about the incident that happened, when it will be maybe there will be an article in the newsletter, okay, like the Oldsmar Florida event. Unbelievable. For a full year, the whole world believed it was a cyber attack. And only a year later, that employee admitted that he did something, a mistake or a stupid thing. I don't know. It was not a cyber attack. Okay. And or the German steel mill. Many people are reporting about the German steel mill as a cyber attack. Yes, there was an outage, there was damage, but are we sure it was a cyber attack? Or maybe it was a failure. Maybe it was an incorrect action of an employee. We don't know. We don't know the situation. And I tell you, I don't know for sure, but I have a friend in Germany who is an expert. And one day he wrote me, Daniel, you should not mention the German steel mill because it was not a cyber attack. I said, wow, everybody say it was. Yes, so everybody said it was, but it was not. It was some kind of other event, but not a cyber attack. So in many cases, no matter if it's published by company A or B or C, okay, no matter if companies are publishing that the growing number of industrial cybersecurity incidents are unbelievable. Yeah, people can write, people can scare their customers. Why? Because they want to sell their boxes. It's all nice. I agree. They want to sell their boxes. But we are experts. I'm talking now to the team who want to be experts in industrial cybersecurity, and we cannot just disregard these things. So furthermore, calculating the risk. It's always important how we calculate the risk. We know the famous formula. We know the improved formula by Dragos, which takes into consideration the deployed defenses and the known vulnerabilities. So yes, put some efforts to understand how risk is calculated. I would like to show here another slide which I created. These are all my slides. I didn't copy it from any paper and from any magazine or from other people. So you see now maybe things you didn't see before. The VLR triad, not very famous. So vulnerabilities contributed by some unknown or known factors. Likelihood is contributed by intention or by resources by someone, and then we have the risk. So vulnerability and likelihood create the risk. On the left side, you see the extended formula for calculating the risk. I know that there is a simple formula which is impact multiplied by probability, likelihood. No, this extended formula is significantly better. And think about it, how you can use at your work that formula. On the right side of the risk, you see what can happen: operation outage, damage, and hurting people. So now we already have the risk, and now we need to going up. How can we reduce the risk? On the right side, we have the famous PPT, people, procedures, technologies. That's the risk reduction possibility. And on the left side, you see a less famous triad, which is the RCD or RDC, redundancy, diversity. Diversity means that if you are using the several firewalls, try to use different firewalls from different vendors, and it will be much better. Then you are going up. Okay, now you go to the SRP triad, and you see the goals of the SRP, which is business continuity and which is safety. So this is a nice slide, also appeared in one of my papers, not the recent one. It was created a year ago, but look at it and learn from it. Business continuity. I want to say something about business continuity. In many cases, we have problem talking to our managers about cybersecurity risk. I say maybe it's a better idea to change our vocabulary and talk about business continuity, because managers understand what is business continuity. And fact of life that in our area, 99% of the incidents are IT directed, and only if there is a business continuity problem, it will be related to the IT. So talk about business continuity and let the managers to decide about how they are going to handle it by adding more IT experts, more OT experts, depending on the plant, because every plant is different. Here is another slide which I created in 2022, a year ago. On the left side, let's look at the center of the slide. You see the vulnerability and the attack enablers, why attack can happen during the vulnerability, and we already mentioned that. And on the right side, the impact intensifier. Somebody has a motivation, create a capability, and then if you go up, you are from this center, you reach the IT zone and what kind of damage you can create to the IT. And if you go to the lower part of that slide, you can talk about the OT. And we already discussed this topic, so I don't want to go more deeply. Look at this slide for 5 minutes and learn from this slide how can you become more professional when dealing with cybersecurity. The conclusion is obviously the industrial cybersecurity must evolve. The fact that there were only two-digit number of incidents, we should not go sleep and relax. Things must evolve. We need to monitor periodically. The situation. We need to analyze the parameters, how they are changing. We need to categorize the assets by criticality. Obviously, if you have an area where you bring water to the power plant, and when you have area where you are controlling the boiler and the steam boiler, it's not the same. It's not the same. A steam boiler can explode. A water control may have some minor problems. Okay. We need to accurately understand the ICS security risk. And you see, I'm repeating, I'm not shy to repeat myself, internal, external, and supply chain related attackers and caused by negligent actions of authorized personnel. Always be ready. People are making mistakes. The first thing that you need to be protected is to react correctly when somebody created a mistake. Furthermore, I want to say that we cannot say that we know how to protect our plant. It's wrong. We don't know how to protect a power plant. We don't know how to protect a water company or a refinery. We need to divide the plant to zones and focus on how you can protect each and every zone in the plant, because they have different functions and there are different criticalities in each area. So how you are going to do that, that's very, very important. Okay. We need to analyze the effectiveness of the incident response team. Soon I'm going to talk a little bit about BCP, IR, and DRP. I need to include that. Additional security controls, PPT related or ISO 27001 related, because now we are dealing with external services, how people behave, and so on. And you need to remember that attackers' capability always evolve, and we must be always a step ahead. So when there is no one day we can fall asleep, we need to improve every day. Furthermore, we have, I think that we have another 10 minutes, so we can talk about 10, 15 minutes before we go to the next area, to the Q&A. So remember, we talk about so many things during earlier hour. But now, what can we really do? Remember BCP, DRP, IR, or IRP, how you want to call it, okay? And I want to say something, and I will repeat it later. BCP, Business Continuity Planning, is a process that you must deal with that all the year, every year, all the time. All the time you need to look, how can I be better prepared? That's very, very critical. So the lifetime of the business continuity preparedness is maybe is months and years, actually all the time. I would like to correct something that maybe some of you have different opinion, but incident response is a matter of minutes. Not a day, not week, not months. It's a matter of minutes, because incident response preparedness, you see a situation, how you are going to respond. You cannot prevent the incident because it already happened, okay? It's not like a car accident that you can prevent, but what action you are taking to minimize the risk to life of people, number one, and what action you are going to take to minimize the damage. And if you not make a decision in the matter of minutes, then obviously you cannot do too much. Finally, we have the disaster recovery planning. I will have a complete session about it in Singapore next month, no, in September, about the BCP, DRP, and IR, because disaster recovery is what you do after the incident response phase is completed. You stop the incident, you prevented the risk to life of people or prevented the risk, the damage. Now, how you are going to bring your facility back to work, it is DRP. There is one more action which is not shown here, is the investigation. Many people think that incident response and investigation are done together. I don't like it very much, because incident response is a matter of minutes. Investigation can be weeks and months, and I cannot glue them together. One important topic is how many teams we need to have to handle this. What is defined in this slide, I want to clearly say a simple answer: one team. Do not consider to split this activity to several teams. You need one team of great people. Why? Because these three actions never happen at the same time. Never. When you are doing business continuity planning or preparedness, everything is good. You relax, you drink coffee, and you think about how to be better prepared. When you deal with the incident, you don't drink coffee, you don't even breathe. Just worry about life of people and damage to equipment. And when you do disaster recovery, it's another process that can be done. So one team should handle all of this. I would like to take this opportunity, because many of you know about my restless fight against the term IT-OT convergence. I don't have too many opportunities to talk to your team, so I would like to say very, very clearly, IT and ICS-OT systems must be separately designed, separately deployed, separately tested, and separately commissioned. If you buy an IT organization, billing, HR, finance, whatever, or even manufacturing process scheduling, and you buy a power plant or a water company, they are not related. Never build them as a converged network. Build them separately. When you complete the separate activity, you ask a very important and very simple question. Why do I need to connect between them? And if yes, what is the purpose? And if I know the purpose, what kind of technology I'm going to use to link between the network? And this is the time for me to tell you again, forget the term IT-OT convergence, no matter if you heard it from your boss, no matter if you heard it from a newsletter or from another expert. Say cyber-secured IT and ICS interfacing, secured interfacing. What does it mean? You understood why you need to do the connection, and you selected the correct technology and process for connecting. It can be a DMZ, it can be a unidirectional gateway, it can be a strong firewall. I don't know, depend on what I need to, why I am connecting with this network. I need to decide about it. Maybe also a question of budget, but need to do that. We are ending towards the end of our session, and I want to bring a couple of things that it's a good opportunity to see them. Maybe, hopefully, we will have an opportunity to meet and then conduct longer sessions. So, what I said earlier about the BCP, business continuity planning, be ready before the attack happens. Know the zones, understand the processes, understand where are the risks, okay? If you deal with the refinery or a power plant or something high-risk operation, you need to learn the term controlled shutdown. You need to understand it's not emergency shutdown, it's controlled shutdown. How to shut down the plant peacefully. You need to learn it because every plant has a different process. Be ready to act after the incident. We talk about the IR and we talk about the DRP. Be ready. Finally, you must assume that event will happen. And if you assume, then then you are better prepared. I would like to show here another slide which I created earlier this year, because I always think about how to explain the important things to people. I am always worried about it. So this is the threat assessment. In the center, you see the security levels, security level 1, 2, 3, and 4, according to 62443. Now it's the good opportunity for me to tell you a secret information. Don't say that you heard it from me. It's secret. These terms, SL1, SL2, SL3, SL4, are going to be changed by the 62443 organization, section 1.1. And we no longer will talk about who might attack us, but new definition will come about the impact. Okay, what is the impact? Okay, if if I understand what is the impact, I think it is significantly better for me to make a decision about investment in cyber defense. If you tell me who is the attacker, yeah, it's great to know, but maybe the new definition which will come out probably later this year, I don't know, but follow the publications about section 1.1, it's coming. If you go to the left about the type of assets, okay, it's already linked to the impact, okay. Maybe in the future I will combine this left side together when the definition will change. So we think about the different type of assets, and the more critical asset deserve more attention. If I go to the center of the slide, I talk about the different type of defense measures, the sporadic internal process, Lockheed Martin cyber kill chain. Very important to understand why it was created and understand how it is working. The MITRE, which is the extended version of the Lockheed Martin cyber kill chain, and not be shy that from time to time you need to invite expert team. And in the bottom you can see the formula. It is another type of formula that calculating the risk. On the right side, you see what I already mentioned several times, the impact. You see, this slide probably will change next year, because the impact can be outage, which is a problematic, but it's the small event. If you don't have water or electricity in your home, it's not nice, but if you have it for 2 hours, you can somehow manage. Then minor damage, severe mechanical damage, and hurting people. So now, what is important? This refers to threat and risk assessment. You need to know how to take this slide and how to translate this knowledge to your facility in order to be better ready. That's the point. Attack may happen immediately, tomorrow, next week, next month, next year. It will happen to everyone. It's not a question of if, it's the question of when. What does it mean? You need to put all your talents or your knowledge in order to be prepared. Another slide, which is taken actually from the 62443 standard, and you can learn from it the typical process of handling the incident. As you can see, it starts with the detection, then it goes to containment and recovery. That's the moment when you don't drink coffee, and that's the moment you don't breathe. You just deal with the incident, okay? Minimizing damage, first of all, minimizing risks to life and minimizing damage, okay? The containment. Then we have the post-incident activity, the analysis, the forensic, and bad news, finally, we need to go back to preparation because the next incident is just a matter of time, and we need to be prepared, and we need to know how to expect the unexpected. Finally, I would like to do a short introduction about what you probably know, the tabletop exercise. The tabletop exercise is now a standard part of the training program. I'm going to conduct a full session in Singapore. It will be a 4 hours presentation, and after that will be 2 days of practicing. And tabletop exercise truly related to everything what we are doing today. We deal with predefined scenarios, how to deal with them. We need to learn how to make critical decisions, how to activate experts and external experts, how to deal with documentation. This is all part of the tabletop exercise. Why it is important? I know the term TTX have several meaning. Some people include also the management. In my case, the TTX is involving only the people who are related to the industrial control system operation and secured operation. It will help you to correctly refer to the BCP DRP IR term. It will help you to detect weaknesses as part of the activity, and later you need to decide who will participate. So quickly I go to then, so we will have enough time for session questions. Typical. On the left side, you see typical scenarios for the TTX. These are the events that can happen to you any moment. A abnormal situation, hazardous material incident, safety failure at any moment. On the right side, you see how you are going to deal with that. And you can take this slide and already bring it to your workplace next week and talk to your manager how we are going to deal with this situation, because as you can see, TTX is very important, and I hope some of you will have opportunity to participate in such a session, and this will be great. Who will participate typically in the tabletop exercise? Usually I like to bring to the podium 5 people, or maybe more people, but representing 5 groups. I always need the plant manager. Why? Because he knows everything. He must know everything. He must know the process. He must know the system. I need the physical security and safety people, the guards who are responsible for safety of people. I need the organization CISO, because he must know everything related to cybersecurity. And then I need 2 more people who are not CISOs, but they are experts, the IT expert, IT cybersecurity experts and the ICS cybersecurity experts. So obviously this chart is applicable for bigger companies that have enough people, but doesn't matter. You know, even if you are watching such a game, some people call it gamification. Now we call it tabletop exercise. Just by watching this situation, you can learn a lot how to correctly refer to an incident. That's important. Finally, I would like to finish with a slide that some of you may know from my previous sessions. On the left side, you see our main goal is always safety. And look at this. If you ask yourself what you need to do, the three important things to achieve your goal, forget about patching, forget about penetration testing, forget about expensive firewalls. Employees training and drills, top priority. Why? Because people can prevent and stop damage. Network segmentation between IT and OT, and network segmentation between industrial zones which have different level of criticality. Okay, and finally, physical perimeter security and surveillance. Difficult to catch everyone who is coming to your facility and have a USB under his lung. Difficult to do that, but at least we need to remember that. Finally, always think about the security goals which are in your specification. Always think about vendors. Which vendors you are ready to work with? Those who take cybersecurity seriously, not those who try to sell you a inexpensive training or inexpensive firewall, inexpensive computer. No, deal with those who take cybersecurity seriously, no matter in what part. Do not compromise on the requirement. If you decide that something is important, then yes, make sure that it will be included in the product. And be ready for surprises, because this is our life. We never know what will happen. And this will be the end of my presentation. And as I promised, we have now about 20 minutes of Q&A. I'm not sure if we can answer all the questions, but don't worry. If you have a question that you didn't get answer, or you are not satisfied with the answer, please send a mail to the organizers or directly to me, and I will make sure that you will get the answer, because we have a one common goal: improve and upgrade the cybersecurity posture for industrial organization. That's our goal. This is the reason, I tell you a secret, that this is the reason I'm working 7 days a week, in order to make sure that I achieve everything and I help everyone who need help. So thank you very much, and I'm waiting for your questions.
All right. Thank you, Daniel. Yeah. So before we go into the questions, there are some of them. So you had written this paper, right? Correctly analyzing and understanding ICS-OT cyber incidents. So what drove you to do that? What motivated you to do that?
Yes. So what motivated me is that I saw a huge gap between what is written in paper. Every paper is starting with the story, the growing number of industrial control cybersecurity, the millions of incidents, and then I listened to some experts. Okay, they say no, actually not too many people happen. And because I'm participating in the 62443 War Group 13, and we raise this topic because we say we are experts. How come there is a situation that we don't understand how to bridge between 2-digit number to 6-digit number? This is what gave me the motivation to spend time to think about it, write the first draft. I let it to read to some people. I get some comment. I'm not saying that this paper is perfect. I never say that my papers or my presentations are perfect, but it gives a fair direction. So just learn from it, and then you decide by yourself.
Thank you, Daniel. So we'll go to the first question asked by Amit. So he has two questions. How you would like to define the emergency shutdown versus a peaceful shutdown, or I suppose he means a controlled shutdown, right? So that is the first question. The second one is how it is going to make a difference for an asset based on the shutdown.
So I tell you, those of you who know my earlier presentations, you know that intervention, that every action is intervention. So I need to be very, when I do intervention with the industrial control system, I assume that some damage will happen to the machine. You all know, some of you heard me saying that when you bake a cake at home, you bake a cake, what you are not allowed to do, you are not allowed to open the door of the oven because this is intervention. So now to answer your question, if there is a risk to life of people, I'm not worried about damage, I'm not worried about outage, I'm not worried about money, I'm worried about saving life of people, and I do an emergency shutdown. I want to clearly say not a down, which I know how to do it correctly, or in some cases where I see that I feel that there is something wrong. I don't really understand, and this is included in the tabletop exercise. I see something wrong. I'm not sure. I cannot investigate it because the plant is working. So I get a permission to do a peaceful, absolutely correct way to shut down, to stop the operation correctly. It may take not 1 minute, it probably may take 3 minutes or 5 minutes. So that's the difference. I say it very clearly. If you see risk to life of people, don't worry about anything. No money, no outage, no cybersecurity. Save the life of people, no matter what it takes.
Right. So moving on to the second question by Ravindra. For analyzing OT incidents, do you prefer shop floor people to be included in the IT, OT, SOC teams to better analyze those incidents?
When an incident happens, we know that there is an IR moment, incident response. It takes 2 minutes, 3 minutes, and that's it. Because there are so many possibilities of internally generated, externally generated, mistaken actions, we need to collect a lot of data, and we need to analyze a lot of data. If you have a deployed IDS, maybe, or in the SIM, security information event management, maybe you are in a better shape. But if you don't have these machines, you need to collect, you need to download the data, analyze the data. So you need all the talents who are available in order to analyze. Look at the syslog output, how it changed. Look at the time. at the time step, how it changed. Look at the parameter of the physical parameter, how it changed, why it changed. Okay, so I would say yes, collaboration between IT and OT people is mandatory. These teams need to help each other. But before they help each other, the IT people need to go through a training session about what is industrial cybersecurity all about. And I'm now conducting such sessions to specifically for IT people. Why? Because I don't expect they become expert after the 5 or 10 hours, but they will be able to communicate with the industrial experts.
Right. Thanks, Daniel. So Amit Singh has a question, and Amit, maybe you can unmute yourself and ask the questions that you have. Keep it short, because others might have some questions as well.
Yeah. Thank you, John, and thank you also to presenting. This is a really good, insightful presentation. Just regarding the previous question, just a quick things. Maybe I couldn't understand still, because while we say emergency shutdown means it is already safe shutdown, because intended to take safely emergency shutdown. Maybe I couldn't understand still well that what exactly mean to otherwise, but okay, that is fine. Maybe we can further try to understand. My second question is regarding suppose if incident something is like observed. So what is the recommendation? Do it immediately to be reported, to be analyzed, then reported? What strategy should be?
So according to BCP, IR, and DRP, the most important action is to do the incident response, meaning contain the situation, relax the situation, prevent further damages. That's number one. When you deal with that, don't worry about reporting, don't worry about anything. Okay, and it takes 2-3 minutes. When you complete that situation, this will involve shutdown, some kind of shutdown of the plant. Then you start analyzing it, collecting data, and reporting. Why? Always remember that when you are doing this analysis, some people might not be satisfied with the result, and the forensic investigation, including law enforcement, might come in, and they will ask further questions. So make sure that you involve also forensic people. Why? Because forensic experts, they know how to collect the data in a way that it's acceptable for investigation and acceptable by the court.
Thanks, Daniel. Is there anyone else
Okay,
who would
thanks.
like to? Is there anyone else who would like to ask question? Just raise up the hand, and I will enable the mic.
Until people come in, I would like to encourage all of you. Look at training opportunities. Convince your manager that training is important. Take every training opportunity. If you are already a CISO and you don't feel that you learned enough about the industrial, ask to find the training, like 8 hours training that talking about principles of industrial cybersecurity. Always upgrade your knowledge. Always read papers. The ICSJWG is an excellent source. Many papers are published on the LinkedIn. I say if you just type my name in the Google, and you will reach many papers which I published somewhere on the internet, and the difference between my papers, and forgive me if I'm convincing you to read my papers, because my papers are always only 2 or 3 pages. I never write long papers because I don't believe that people have time and patience to read long papers. I take a topic and I write 1,000 words or 1,500 words, which you can read it in 5 minutes. Furthermore, the ICSJ, the work groups of ISA 62443 have activity, and we are now writing MLM. MLM is micro learning modules. These modules are already in process of writing. Unfortunately, the publishing is a complicated process, but every MLM will have only 12 slides. 10 or 12 slides, and this will be a recorded session that you can listen to that in about 10 to 12 minutes. So we are planning to write about 100 MLMs on different topics. One topic is the secured IT-OT interfacing, which I wrote. Another MLM is that PLC programming. Another MLM would be the 0 day for industrial control system. Each of these will be recorded, and you can listen to that during 10 to 12 minutes. So truly, we are doing our best to make sure that everyone will have the opportunity to learn, because that's the main goal of this whole activity, that people upgrade their knowledge and people upgrade their cybersecurity posture of their organization.
All right, so we have some more questions. Himanshu is asking, who should declare the incident? Operators generally don't understand cybersecurity details, as they are the ones present. Is real-time monitoring necessary?
Well, operators, for sure, they don't understand, although there are today already operators, some of them were training at my sessions, who learn how to detect. But remember, in the operator room, there is always a senior operator, a senior person who is more knowledgeable, but they need to acquire the knowledge to understand the level of the risk. If they see a boiler which have high pressure, or some type of a turbine which increase the temperature, or some kind of chemical facility which increase the percentage of chemical material, they need to be authorized to run emergency shutdown, because something bad can happen, and there is no time to make meetings and consultations. You need to decide in a matter of minute or two.
All right. So Mahmood is asking, what are the tools normally used to analyze the incident?
First of all, depending on the system. If the system have an IDS, then you have a lot of information. I would start with the Purdue level 0. What happened there? Was overheating. Then I would go to Purdue level 1. Why the PLC allowed that incident to happen? Remember the Oldsmar, Florida situation, that they claim that the PLC allowed to increase the level of chemical multiplied by 100 of the normal. So I would start at Purdue level 0, go to Purdue level 1, go to Purdue level 2, and then understand why a specific incident or why a failure turn to an incident. Okay, why failure? If a sensor is failing, if a temperature sensor is failing, doesn't matter that explosion can happen. There must be somewhere another sensor who will stop that process. So it always depends how the system was designed. If the system was designed correctly, you are in a much better situation.
All right. Thanks, Daniel. Moving on to the next one. Ali is asking, I would like to know how we may define the scope under consideration for the assets and how we categorize OT assets which are critical that need to be monitored for incidents, and who would be responsible for categorizing the assets.
So as you remember the slide which I showed earlier about secured IT-OT interfacing. First of all, make sure that that IT and OT and will separately designed. Number one, separately designed. Then if you speak about monitoring, if you can put a data diode, it's just for monitoring. Pull out the information from the ICS zone to the IT zone, and then you do whatever you want. Okay, but so depends on the criticality, what that industrial control system is doing. If that industrial control system is doing a high-risk chemical process, it's one thing. If that process is just dealing with the water supply, it's another thing. So, as I always say, we must understand the process, we must understand the criticality, we must understand the business continuity consequences, and we must understand the risk to life of people. If you understand your system, that's what makes you different between the IT people and ICS-OT people. We understand our system. We understand the consequences. And then you can find the answer on your question by yourself.
Right. So Shanid is asking, which one is decide risk assessment, qualitative or quantitative, and what is the method that you follow?
Sorry, can you repeat the question?
So when we speak about risk assessment, we have qualitative and quantitative risk assessment. Which one is decide, and what is the method that you follow?
I tell you, I think that these questions are coming from people who are trying to create some problems, I would say. Understand the process at your plant. Number one, understand the risk, understand the consequences, and build your process accordingly. That's the most important. If you take the IT people who don't understand the industrial process, they can bring you all kind of theoretical methods, and then what can you do? Nothing. So I don't have a good answer because it's all related to the specific plant, to the specific criticality, to the specific risk to people. It's all about that. Sorry, I don't have a direct answer. That's the way I usually work. Understand the process.
Right. Okay. All right. So there are a few people who would like to ask some quick questions. I'll enable the mic now. Kindly be very brief so that others can ask as well. Chakrapani, you can unmute yourself and ask the question quickly.
I can't hear the question.
Chakrapani, are you able to? Your mic is already enabled. You can unmute yourself and ask the question. You can try now quickly. All right. So while we wait, let me. Okay.
John, you can share your screen and then continue.
Pawan, I have enabled your mic. Maybe you can ask the question quickly.
Yeah, sure. Thanks, John. Actually, I have one quick question. So, suppose in a scenario like where I can see like engineering station or operator workstation, which is sending like lot of DNS queries to the external or public IP servers. So, in that scenario, like how we can proceed further? So, to investigate on that, like see, that is not expected in the planned network. So, to talk with the external public IP servers. So in that scenario, like how we can handle, like how we can propose a solution to the customer.
Sorry, can you ask a short question? Can you translate it to a short question?
Yeah, sure. Generally, like see some of the like see workstations.
Pawan, maybe you can speak a little bit slow so that he's able to understand the question.
Okay, sure, John.
Yeah, go ahead. Thank you.
Yeah, thank you. Generally, like see in industrial control systems, like where you can see like engineering workstations, operator workstations are there, right? So sometimes I'm seeing like see while handling the incidents, so we are seeing the like DNS queries, like which is talking to the external public servers, like I can say Google DNS or external DNS servers. So in that case, like what we can recommend to the customer.
I think that, it's very difficult for me to answer a question without looking into a specific system. But what you need to recommend to your customer that they should involve an expert related to their process, related to creating a process for BCP, IR, and DRP. Okay. This is the best what you can recommend to your customer, documentation and in understanding the process and deploy a BCP, DRP, and IRP process. That's what you can recommend to your customer. Otherwise, it's very difficult for me. I need to visit that plant, talk to the management, understand the process, and then perhaps I have a more accurate answer.
Okay, yeah, thank you.
All right. Mahmoud, you can go ahead, quickly ask the question, unmute yourself, and you can ask.
Thank you, John. I have two questions. During the incident, what shall happen first? Contain the incident or analysis the incident to maintain the safety and operations? The other question, for example, if I have...
Sorry, what's the first question?
Okay. During the incident, what shall I do first? Contain the incident or analysis the incident to maintain the safety and operation for the plant?
I think I did answer that question. That the most important action is incident response, which is stop the incident, stop the possibility of people get hurt, and stop the possibility the damage to machinery. When everything is relaxed, then you have a drink a coffee, relax by yourself, and then you start with the investigation.
Thanks. Another question. For example, when I lose a critical application, for example, the safety shutdown system, how can I react?
If you have an emergency shutdown system, you said?
Yeah, if the incident attacks the emergency shutdown, how can I react?
First of all, I believe that if the emergency shutdown was activated, it means that your plant will shut down no matter what.
Not activated, attacked, but not activated. I cannot activate it.
That somebody is acting the emergency shutdown. I think that this is what happened in Saudi Arabia in 2017. That the attack was done, and I think that that if the plant is a critical plant, you need to shut down the critical parts of the plant and call the vendor of that emergency shutdown system and ask a question why it was possible to attack it. Maybe not the vendor, maybe your IT people, because emergency shutdown must be a system which is strongly isolated from the industrial control system and for sure strongly isolated from the IT and from the internet. But there is a possibility that a human person created an internally generated attack to shut down, to disable the emergency shutdown system, and then you have a problem. Yes.
All right. Thank you, Mahmoud. Kumar, you can unmute yourself and quickly ask the question.
Yeah, thanks for the opportunity, John. So, Daniel, I have one question related to ICS cybersecurity. What are the hard areas that can be R&D? Many of the PhD people will be taking research topics. So, in ICS cybersecurity, which are the challenging topics which can be R&D?
John, can you repeat the question, please?
Right. So what Kumar is asking is, he wants to know, OT systems have a lot of challenges. So when we talk about R&D in cybersecurity, what are the topics that can be focused for the R&D research?
Well, I tell you, if you look at the ICS 62443, section 4.1 and 4.2, okay, this is where your R&D should be focusing. Your R&D should be focusing on assurance of operation reliability and assurance of operation safety and prevention of any kind of manipulation. But again, it depends on the plant, because if you have a highly critical plant, it's one topic. If you have a non-critical plant, is another topic. So you need to understand what are the consequences if something will happen to this plant and focus your R&D to that area.
All right. Thanks, Daniel. One more question, and I think we can. Chakrapani, you can go ahead. The mic is enabled. You can.
Yeah.
Yes.
Hi, Daniel. So
Yes.
what is the difference between industrial OT and medical OT? Industrial OT, we have Puru Model, but what about medical OT?
Well, I tell you, in the area of medical, I think that majority of the systems are a sort of intelligent electronic devices and probably very similar to IIoT in the medical area. So in the medical area, you don't see a power plant, okay? You don't see a Coca-Cola factory. That a medical typically it's the single very specific processes. So what you need to focus is that these processes are well protected and isolated as strongly as possible from other zones. You need to define each of these as a zone. and make sure that no one can penetrate, that manipulate that device, because this is the big risk. If you have a medical appliance which is connected to the intranet of the facility, and someone may manipulate it, yes, that's the main risk. And I can tell you that unfortunately worldwide there is a huge problem of medical systems which are not and not securely designed. It's changing now, but we are in the middle of major problem, and I think that there is a specific group that is discussing this topic, and I believe tomorrow there is a presentation about medical security, right?
Yes, yes, Daniel. Yeah, tomorrow morning we have one.
Thanks, Daniel.
All right. Yeah, I think that's about it. So I think we can wrap the session quickly.
So if Daniel, you have any of the incident details, and if you can just showcase those analysis to us, that would be a very better kickstart for everyone to understand in detail.
Well, I tell you, there are as I said, there were not too many ICOT directed incidents. And even if you read all the papers about this, you will always see the same names. So probably the number of published incidents are around 30. And not all of them were analyzed in detail. So the most important incident, which was the Stuxnet, there was a movie about it. There are many papers, and you can read professional analysis. But I think that the best all of us can do is to learn this topic, read papers, listen to workshop sessions, take some training classes, and learn from everyone who is willing to teach at least as I am willing to teach.
Okay. Thank you, Daniel. Thank you for your wonderful insights. I think we are already 15 minutes over. So it's time to just go and say goodbye. But thank you so much for arranging your session. These sessions are always enlightening.
Perfect, guys. Thank you.
Yeah, thank you, Daniel. Thank you, everyone, for participating today. Look forward to your active participation and feedback regularly, and see you in the next event. Thank you.
Thank you.